Ethernet technologies. Overview. Ethernet is a family of networking technologies used in local area networks, LAN, which are defined under IEEE 802.2 and 802.3 standards. It is the most widely used LAN technology family used today. Ethernet and the OSI model as shown in Figure 1, Ethernet standards define both Layer 2 and Layer 1 technologies. At the data link layer, Ethernet relies on two separate sublayers to operate: the logical link control sublayer and the media access control sublayer. LLC sublayer. The LLC sublayer is used to communicate with the upper protocol layers of the OSI model. It takes the protocol data units, PDUs, from the upper layers, which are typically IPv4 packets, and adds control information to help deliver the data to its destination. LLC sublayer is implemented in software, and its implementation is hardware agnostic. An example of the LLC can be considered the network driver software of a server's NIC. The NIC driver is a software program that interacts directly with the NIC hardware and passes the data between the MAC sublayer and the physical media. MAC. Sublayer MAC constitutes the lower sublayer of the data link layer. MAC sublayer is implemented in hardware, typically in the server's NIC. Ethernet MAC sublayer has two primary functions: data encapsulation and decapsulation, frame, delimiting, addressing, error detection, media access control, control of media access media, recovery, data encapsulation. The data encapsulation process includes forming the frame, adding Ethernet header and trailer, and decapsulation of the frame upon receiving. It provides three primary functions. Frame delimiting. This process provides bit-level synchronization between the sending and receiving nodes. It also signals the receiving node about the start of a new frame. Addressing. This process adds an Ethernet header to the frame. The header contains the physical addresses, MAC addresses, that are used by the network devices. Error detection. Every frame has a trailer with a cyclic redundancy check, CRC, of the frame contents. The receiving node calculates again the CRC, sum, and compares it to the one in the frame. If these two CRC calculations match, the frame must have been received without error.